This is Team T12G02, and we're excited to launch our new campus game app, Catch Me, with the thrilling slogan, Catch Me If You Can. Designed for the University of Melbourne, this multiplayer game takes place on a real-time map, encouraging players to explore campus and enjoy fun interactions with others. Now, let's meet Josh. Josh is a new international student who recently started with his bachelor's degree. He's unfamiliar with the campus and hasn't made any friends yet. One day, as he's passing through a building, he notices a poster on the board. It's an invitation from the university's social club to join a game called Catch Me If You Can. Josh learns more about the social club and meets one of its members, Chris. Chris explains the rules. To join, Josh just needs to download the Catch Me app from the App Store. Eager to connect with others and explore the campus, Josh downloads the app right away, excited to dive into the game. With Catch Me, students like Josh can explore, interact, and experience campus life in a whole new way. Before the game begins, Chris opens Catch Me, selects Create Room, and a QR code appears on the screen. Josh, Jack, and other players scan this QR code to join the game as mice, while Chris, as the room creator, takes on the role of the cat. To give the mice a head start, the cat, Chris, must stay in place for a few minutes, allowing Josh, Jack, and the other mice time to explore the campus and given distance from mice. Josh and Jack start off together, looking at the map to plan their routes. Josh, eager to find treasure, decides to head to the engineering building, where a treasure box is hidden. Jack, an art student, chooses a different path, aiming for the art building to find another treasure box. The two separate and set off on their own adventures. Once Jack reaches the art building, he realizes the treasure box isn't as easy to find. Suddenly, he notices Chris, the cat, closing in on him within the 15-meter catch range. In Catch Me, cats can track the mice's locations on the map, but mice only see each other's positions, not the cats. Unfortunately for Jack, he's caught by Chris and is now out of the game. The chase continues, with Chris hunting down the remaining mice as they explore campus, looking for treasure and staying out of the cat's reach. Back to Josh, our lucky player, who has followed the map and found a hidden treasure box. He taps his phone on the treasure box sticker, unlocking magical items that are added to his inventory. The first item is an invisibility cloak. When used, it allows Josh, as a mouse, to become invisible to the cat for 30 seconds, hiding his position from Chris. If Josh senses that Chris is nearby, he can activate this cloak to escape undetected. The second item is a decoy, creating a fake mouse that appears near Josh's location. This decoy moves around, confusing the cat and diverting attention for 20 seconds. Since Chris can't catch a fake mouse, this item adds an extra layer of excitement and strategy to the game. Josh is doing exceptionally well, using these tools to stay one step ahead of the cat. Shall we move on to the production and technical roadmap? Our product design focuses on 6 key features to deliver an exciting experience for users. First, the QR code scanning serves as the gateway to the game, allowing users to quickly and easily join by scanning with their phones. Next, the campus-restricted map enables real-time position sharing, where mice players can see each other's locations but not the cats, adding a layer of suspense. NFC stickers are strategically placed around campus, encouraging exploration. By tapping these stickers, players can collect items, which then appear in their item lists for easy tracking. Finally, the About and Quit options provide basic project information and allow players to exit the game at any time. We conducted heuristic evaluations, focusing on aligning the game with real-world interactions and giving users flexible control. This thoughtful design ensures an engaging and seamless gameplay experience. Here's our app in action. When we open the app, it initially directs us to the map fragment. However, the first time we enter, no players are rendered on the map, as we haven't created or joined any room yet. A hint pops up to inform us of this and guide us on the next steps. First, we need to go to the top of the map to create a room. Once the room is created, a toast message appears, displaying the room ID. Then the map will render several powered-up items, including NFC stickers, which we can use to locate these items. As the game begins, cat player will be represented by a cartoon marker on the map. At the top of the screen, there's a display showing the current number of uncaught mice we need to catch, along with a catch button. By tapping this button, we can catch any mice within a 15-meter radius. If players are looking to join an existing room, we can use the Join Room menu option. This will open a QR code scanner, allowing us to quickly join the room by scanning the code. Once a player locates an NFC sticker displayed on the map, they can tap their phone on the sticker to collect magical items. The collected items will appear in the item list, where players can check which items they have and view their quantities. By clicking on an item, players can view its details and functionalities. They have the option to use it whenever they choose. The About page provides an overview of the game, and players can choose to quit at any time during gameplay. Based on our usability heuristic evaluation, we designed the game to give users flexibility and freedom, allowing them to control their experience seamlessly. The app's entry point is the main activity, which launches the home fragment to render the map. The item list fragment displays collected items, and selecting an item brings up its details in the item detail fragment. QR scanner and join room fragments handle QR code tasks, while the NFC controller manages actions when users tap an NFC tag. For database queries, the Firebase Manager acts as a proxy, retrieving and delivering data as needed. We utilized the NFC adapter and def libraries to manage NFC functionality on Android devices. Through the NFC controller class, we implemented read and write operations for NFC tags. Each time a player scans an NFC tag, the NFC controller calls the Firebase Manager to update the player's item count. Additionally, the NFC controller includes a cooldown mechanism to prevent frequent scanning, ensuring a balanced gameplay experience. Also, we implemented QR code scanning using the Compound Barcode View library, which supports continuous decoding of QR codes. In the QR scanner fragment, the scanning process begins with a camera permission check, followed by setting the scanned room ID as the player's room through the Firebase Manager. To validate QR codes, we verify the prefix of the scanned content to ensure it's a valid room ID. The QR code generation feature is implemented using the QR code writer library, which encodes the room ID into a QR code image. In the Join Room fragment, QR code writer encodes the room ID, allowing other players to scan the QR code to join the room. The generation logic verifies the validity of the room ID before displaying the QR code image on the device. In addition, we use Firebase Manager handles all interactions with the Firebase real-time database. Using methods like getRoomDataAsync and addPlayerData, we implemented the storage and management of player and room data. Firebase Manager extends view model, allowing it to be shared across different fragments seamlessly. It also supports multi-threading to minimize blocking and enhance efficiency. By centralizing all database operations, Firebase Manager simplifies the codebase and makes it easy to extend functionality in the future. In the home fragment, we used the Google Maps API to display the player's real-time location. Before accessing the user's location, the app requests location permissions to ensure users are informed about the sharing of their data. The map update logic utilizes Firebase Manager with fused location provider client to obtain the player's location whenever it changes. Using location request, the app periodically updates the player's location data in Firebase, enabling other players to view these updates in real time. The item system features its capability of dynamic update and adaptability. The item data of a player was retrieved and held as lid data in the Firebase Manager, which enables the item list fragment to be notified of any update in the database in real time. The fragment was implemented with Recycler View, which adjusts itself dynamically according to data provided, which increases the extensibility of the application. Each row element in the item list fragment provides access to the corresponding item detail fragment with data passed along by bundles. Thus the data in the detail fragment would also reflect the updates in database, which ensures the consistency of the data. The invisibility feature for mice uses a visibility flag in the database. When a mouse activates the cloak, this flag is set to false, hiding its position from other players. The decoy feature works by adding a decoy player in the database, with its position updated randomly. All players see this decoy as a mouse on the map. Both items have a limited duration, controlled by a thread that resets their states after time expires, either by restoring visibility or removing the decoy. Let's go back to Josh. After an hour, Josh has successfully avoided being caught, explored the entire campus, and met many players and students along the way. Returning to the social club, he's awarded a Survivor prize for his impressive gameplay. Overjoyed by the experience, Josh decides to join the club right away. This game has not only helped him feel more connected to the campus, but has also allowed him to make new friends and feel truly at home. Thank you for watching. We hope you enjoyed it.